Have you ever wondered why, when you squeeze a toothpaste tube, toothpaste comes out from the top? Or why when you press a bicycle pump, the air moves from the pump into the tire? These are everyday examples of pressure at work. But what if I told you that there's a fundamental law of physics that governs these phenomena? Welcome to the fascinating world of Pascal's law. Imagine a small, closed box filled with a fluid. When you press one side of the box, the fluid doesn't just move on that side. It moves everywhere within the box. This is the essence of Pascal's law, named after the French scientist Blaise Pascal. It states that when a change in pressure is applied to an enclosed fluid, it's distributed evenly throughout the fluid. Think of it like this. Picture a group of people in a room. If one person starts to move, it's likely that others will have to adjust their positions as well. The same principle applies to pressure in a fluid. When you apply pressure at one point, the entire fluid must adjust to accommodate this change. Now, what happens if the box changes shape? Suppose it becomes longer and narrower. The pressure you apply at one end will still spread throughout the fluid, but now it has to travel a greater distance. This is why when you squeeze a tube of toothpaste, the paste comes out at the other end. The pressure you apply is transmitted through the paste and pushes it out. And what about the bicycle pump? When you press the handle, you're applying pressure to the air inside the pump. This pressure is transmitted through the air and into the tire, causing it to inflate. So the key points to remember about Pascal's law are: firstly, a change in pressure at any point in an enclosed fluid is transmitted undiminished to all points in the fluid. This is why squeezing one part of a fluid-filled object affects the entire object. Secondly, the change in pressure is equal in all directions. It doesn't matter where you apply the pressure, the effect will be the same throughout the fluid. And thirdly, this law applies to all fluids, not just liquids. So whether you're dealing with water in a bottle or air in a balloon, Pascal's law holds true. In conclusion, Pascal's law dictates our daily interactions with pressure, from the simple act of squeezing a tube of toothpaste to inflating a bicycle tire. It reminds us that pressure, no matter where it's applied, will always find a way to distribute itself evenly. So next time you squeeze that toothpaste tube, remember you're not just brushing your teeth. You're experiencing a fundamental law of physics.